I have the pleasure of talking to you today about programming. The talk is titled Zombies and Binary, and before I begin, I would like to thank the conference very much for having me. I'm sure you can agree with me the talks today have been awesome, and the food has been great, and it's been really exciting. We've learned a lot, and you're about to learn more, so thank you very much for the organizers, if there are any in the room. You've probably noticed that this is not PowerPoint. Hands up if that was confusing, right? So this is not PowerPoint. This is a game called Minecraft. It is slightly modified in as much as I can put custom slides like this in, and there's a different texture pack. But other than that, everything you see is completely plain vanilla Minecraft. I've selected this venue to host the slides because games are actually a pretty big deal. It is estimated that in 2017, the free-to-play games market alone on desktop and mobile brought in $82 billion worldwide, but that's just free-to-play games. That excludes AAA games, that excludes games people have to actually buy or pay subscription fees for. You can tell it's the second last slide of the day. If you're interested in where that data comes from, like I was, then here's a link for that. So if you're watching a video, if there is a video later on, you can go to this or take a photo of it if you care about those stats, or ask me later. I don't care which one you choose. This specific game, Minecraft, is played by lots of people for lots of different reasons. Hands up if you know someone who plays this or has played it in the past, or if you've played it in the past. A lot of you, yes. It was made by a Swedish guy named Marcus Persson, who sold it to Microsoft, so I guess this is my first and only Microsoft tech stack talk, until I do something about GitHub, I guess. And there are some things about Minecraft that draw people to it. The name is made up of two verbs. One is mining, so you can mine blocks of resources in the game, like these blocks of iron. And then you can either place them down again, like in the case of chopping a tree down, you can build a house with wood, or if it's valuable ore, you can smelt that down into bars, and then you can make things with that, like armor or weapons or other tools. Okay, so mining is one part of this. The second verb, crafting, also deals with the kinds of blocks you can pick up, but as in the case with this piece of tree, you can craft it into different things, like one oak wood log can be crafted into 4 oak wood planks, and planks can be crafted into sticks, and so forth, and so forth. Those two aspects alone take up a lot of the time of Minecraft players. But there's another reason people play Minecraft as well, and it is that in the early stages of this game, it was a very fun, creative thing to do. There was a mode dissimilar to this one called Creative Mode, and in that, you get access to infinite amounts of every block in the game. So people would use this mode to construct works of art, or to reconstruct things that are in the world. People who have mapped out their cities or built life-size models of the Enterprise from the series Star Trek. That's really creative, and that's why some people play it. This mode that we're in at the moment is called Survival, and the goal is to survive. You collect resources, you collect food, you build a house, and at night, though I've disabled that for the purposes of our talk, and so that I'm not overwhelmed, at night, hostile enemies spawn, and you have to survive against them. Hence the name Survival. I don't play Minecraft for creative or for survival aspects. The only reasons I open it these days are for a thing called redstone. Hands up if you've heard the term. Yes. So this is another gatherable resource in the game, and it has some very interesting properties. You find it in blocks that look similar to that, only it's red. When you break those blocks, it looks something like this. And it is a resource that you can use to construct other, you can think about them as electronic components. When you place it down on the ground directly, it creates kind of like a trail. And this trail acts like the silver lines on the bottom of a circuit board. It conducts a charge. Let me demonstrate that for you. This over here is a pressure plate. When I step onto the pressure plate, it will emit a charge, and that charge will travel along this trace of redstone wire into that light bulb, shush, and light up this lamp. Right. So there we go. That's pretty cool. And redstone was added to the game to be able to allow players who are constructing mansions and dungeons and castles to light those things up at night. So they could put lamps in their houses to give themselves light at night. Oh, stop it, this mouse. They could put lamps in their houses to give them light at night, and then they could switch the lamps off during the day with switches or levers or pressure plates. Pressure plates also incidentally work to open doors. So if you put a pressure plate in front of a door and you stand on that, the door will automatically open. It's kind of convenient. Redstone does a lot more. But before I get there, I want to draw a comparison. Who of you in this room are not Amsterdam? Who of you in this room are not programmers, by show of hands? Right, you're all programmers. You will have identified, or be able to identify, this code. It's an if statement. It takes two Boolean things and creates some kind of combination of that to say, if everything inside these round brackets are true, then do what is ever in this first body of curly braces. Okay, we know that stuff. And we have it all over our applications and all over our frameworks and all over our libraries. If we're doing something commercial, for example, we need to check if the user is authenticated before we show their profile, or if they have enough credit on their credit card before they're allowed to purchase a product from our store. We do this all the time, and it's not just in PHP. It translates to Ruby or Go or JavaScript or anything else that you write. I've never seen a programming language that does not have a way to do a conditional statement, and that's because they're supremely useful. Branching on logic is core to what we do as programmers. So what does this have to do with Minecraft? Well, let's go back to our redstone. If we take a log and craft planks from that, and then craft sticks from that, and combine the sticks with redstone that we've collected, we can make that thing, which is called a redstone torch. It's similar to the pressure plates and the switches. It emits a charge. It's different from them because, by default, it's always on. That is, unless you put another charge into it. If I switch the switch on, that redstone wire will get a charge, and the charge will flow into this block and up to this redstone torch, and the redstone torch will turn off. Okay, so why is that useful? It's a knot, exactly, it's a knot. Okay, let me show you a way that we could practically use this. That was very good, thank you. Okay, back to our light bulb example. We have a thing that can emit a charge. We have some wire that can transmit that charge. It'll flow into the block, up into the lamp. We switch the switch on, the light goes on. Now, if we want to invert that process, if we want to say the lamp is on unless the switch is on, we can flick the switch, charge goes into there, up through the block, switches the redstone torch off. That no longer gives a signal to this wire, and the lamp turns off. Let me step a bit back. It's not. It's signal inversion. Now we have this concept in programming. If you refer back to our conditional code, if we put an exclamation mark in front of one of those variables or in front of one of those conditional arguments, it's going to ask for the inverse of that. But we also have that concept in electronics, and I'll show you why that's interesting in a moment. Before we get there, there's one more thing that I want to demonstrate about Minecraft electronics, and it is this. I have a switch. It is switched on, and so this wire is getting power, but hold on, it's getting a bit dimmer, 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 dimmer. It stops over here, the lamp's not on. Oh no. Who of you have ever been in a really big house or a house with many little rooms, and you've got your Wi-Fi router in one room, and you're trying to connect to it across the house, and oh, it's not strong enough, I can't connect, I have to move closer to it. Can anyone remember the name for that? The English name for it, because I don't know that. Yes, maximum suckage, yes. If you know the Dutch name, maybe say that. I don't know the Dutch name for it. Okay, in English, that concept is called attenuation, signal attenuation, or charge attenuation. And that exists in Minecraft. It can go up to 15 or 16 blocks from a power source, and it gets progressively dimmer, as you can see, until it can no longer power anything. Minecraft has a thing we can use for that. But before I give you the name of it, maybe you can tell me, in that Wi-Fi situation, what's the only solution apart from moving the router or getting a stronger router? A repeater. Who can guess what the name of this component is? Yes, redstone repeater. If we put that in line, and it has even the weakest signal, it will light up, and re-amplify the signal. It's exactly the same as a Wi-Fi repeater. It looks a bit weirder. You wouldn't really put this on your floor, but you get the idea. Okay, so we've seen redstone and redstone torches, and we've covered the concept of things that emit and things that conduct and things that react to current. And before I show you what I'm going to show you next, we can also think of current in this case as truthiness, the Boolean true. What if we wanted to, ooh, jumpy. What if we wanted to create a circuit that was akin to the programming or conditional statement? If we wanted to say in our code, if switch 1 is on or switch 2 is on, then do this thing. And this thing, in this case, is light that lamp up. We could create, go away. We could create a Minecraft circuit like this. If switch 1 is on, or if switch 2 is on, then do that thing. They can both be on, and that's fine. But in this case, we only care about one of them being on or the other being on. This is a Minecraft representation of that OR Boolean operation. How am I doing so far? You're supposed to nod and look encouraging. Yes. Okay. That's one thing we can do. What if we want to change that around and say, okay, we want that lamp to go on if the switch is on and the switch is on. This part's going to blow your mind. Both of these can emit a charge into this redstone, which goes into this block. So that switch can power that block, and that switch can power that block. And if they do that, these redstone torches will switch off. However, in this particular arrangement, this redstone wire still has a charge. They're not switching each other off. And because this redstone wire has a charge, this redstone torch is off. And so it's not emitting a charge into here, or into here, or into here. If we switch one of these on, one of the torches goes off. But that's still got a charge. We have to switch both of them on, to switch both of these off, to switch that off, to switch that on, to switch that on, to power that, to power that. What? What's going on? There are more elegant ways to construct this circuit. But I'm not going to talk about any of them. This is just good enough. We've got our OR circuit at the back there, and we've got our AND circuit over here. Okay, how am I doing for time? Show me the time. Come on. Okay, we're doing fine. I want to show you how this is useful beyond just a really confusing configuration of blocks in Minecraft. Who of you here have done any hobby electronics? Okay, a few of you. Of those of you who have tried to construct something akin to a matrix of LEDs that you can put lights through and make patterns on and shapes on? 2 people, that's awesome. I wanted to do this one day, and so I used Arduino, which is a hobby electronics board that looks like this. But I came across a problem, because the Arduino has a limited amount of inputs and outputs. On this particular model, there are 13 ways that I can light an LED up. If I wanted to have a matrix of 8 by 8 LEDs, that's 64 outputs I need. I've got 13 on the board. What do I do? There are some systems that are designed to get around this limitation, but I didn't understand any of them. So I asked an elderly gentleman who I'm friends with who works at a hobby electronics store, and he pointed me towards a component that he knew about that I'd never heard of, and it was called a 4051 chip. Let me show you what it looks like. I have a picture of it right here. Come on. No, why am I flying? It looks like this. Okay, it doesn't look very special, does it? This chip has enough pins on it that it can be controlled by 3 inputs. And depending on the configuration of those 3 inputs, it can control 8 outputs. How does it do that? Can anyone hazard a guess? Sorry? Can you rephrase that in a way that I want the answer? Okay, let me ask about this. What relationship is there between 3 and 8? Binary, yes. Who said that? Put your hand up. I want to congratulate. Yes, come on, come on, come on, come on. Good job. Binary. This chip uses 3 inputs, and based on the 1 or 0 of the charge going into those inputs, it selects 1 output. That makes sense, right? Because you can represent 8 with 3 binary characters. So how does this work? Anyone hazard a guess? It's just a lot of AND gates. It's just a lot of AND gates, right? What we want to say is, when all of these are off, it's got to select the first output. So when all of them are off, the first output is selected. Because binary goes from right to left, if we switch that on, it's binary 1, that's the second output. If we want to count to 3, what do we do here? Oh, so clever. Output 3. What about output 4? How do we count to 4 in binary? And so on, and so on. Right, so this is just AND gates, right? Let's turn them all off and let's look at what the one channel is doing. These combinations look horrible, but this line over here is going there, and this middle line is going there, and this line is going there. Does that make sense? Okay, they're all inverting and using the result of that inversion in an AND gate. If all of these are off, then how do I say light this up? Well, if they're all off, I need to turn them all on, and then you need to check if they're all on. And I can do that. I invert all their signals. I have one AND gate, which feeds into another AND gate, which supplies charge to there. What about if I turn the one on? That's going to be binary 2. So now this charge is going through here, but I don't need to invert it anymore, because that's the charge I expect to be on. I have my 2 AND gates again. The second input is on. Now, I'm not going to go through all of these, and perhaps it's a little confusing, and that's okay. What you should be able to see here is that we are modeling a real-life electronic chip that uses binary to select one output of 8 possible outputs from 3 possible inputs. If you have 2 layers of this, you have more outputs than you need for my 8x8 LED matrix. And all you need is 6 inputs. That's really cool, hey? You're multiplying 6 outputs into 64 outputs, and all you need to do is some binary logic to do that. And we can model that electronic component with AND gates from Minecraft. Let's look at some more cool things. Oh, no, not that one. That's the wrong one, not single player. What are you doing? I have to be in multiplayer, and I'll explain why just now. Okay, let's look at 1 or 2 more programming things that Minecraft supports. Oof. Minecraft is map-based, and it will continue to generate more mapping area as I walk further and further out into the world. It is sort of like an infinite map. We know because of the constraints of memory we can't have an infinite map, but for our purposes it is. It is a direct mapping of the available memory we have on the operating system that is put into use to create a very large map. And everything in Minecraft has a coordinate. Let me show you some very scary logging stuff. Please be calm. What? Look at this. This over here, this block line here, has some coordinates, an X, a Y, and a Z coordinate. This over here has coordinates very near the same thing. This line up here is actually where I am in the world. I am at -334, 64, Y, and 451, Z. If I move, watch how that moves. Check the X number all the way on the left. And if I move on the other axis, check the Z number all the way on the right. Okay, that makes sense. The game's got to know where I am in the world, right? The thing is, everything in this world, including the blocks of air I can walk through, has a coordinate. Does that remind you of anything? Let me put this logging stuff off because it's horrible. We have commands in Minecraft to be able to detect for the presence of a person or a block, and not just if a block's there, but what kind of block it is and what properties that block has, just by running a command to inspect a certain position on the map. I can demonstrate this for you. Again, mind the logging text that you see. As I move around, look at those coordinates that display there. And this happens because I have watches on each of these blocks I could be standing on that detects for the presence of the player. Now, if you're particularly imaginative, you might have come to the conclusion that this represents a map of memory. Because we can tell where someone is or where something is, we can basically treat the whole Minecraft map as memory, and the coordinates are references to what's in that memory. We can put stuff there with commands, and we can read stuff that's in those positions with commands. We can act as random access memory in this map. Okay, that's useful. And using all of these concepts we've seen, and magical blocks called command blocks, which I'm not really going to go into much detail with yet, people have done really interesting things in Minecraft. There is a map I'm not going to open because it's so slow, but it looks like this. It's just a lot of redstone and garbage. Someone has taken these concepts and they've put together a computer inside Minecraft, which runs on your computer. This is the world's earliest vagrant, or virtualization. This has some features. It can do these mathematical things. Squares is particularly impressive to me, but this is what it can do mathematically. So it's more powerful than your calculator, although not your smartphone watch. In terms of multimedia, it can do these things. It's got 3 stored tracks. You can play 3 different games, including noughts and crosses, or tic-tac-toe, which includes AI. So you can play against a computer running on Minecraft on your computer. You can store 14 bytes of whatever memory you want to in this computer and read it again. And it's got a keyboard and mouse. The mouse is kind of off screen, but the keyboard, you go and you stand on these keys, and you can see the typing happening on the keyboard. I've got pictures here because it's actually very slow on this pithy MacBook. But it's pretty interesting, right? That's a really creative use of this. Someone's able to make a computer based on the components in Minecraft. And that's because, along with the trick I will show you in just a little while, Minecraft actually is Turing complete. That's cool. Okay, I've done some interesting things with this. And unfortunately, I'm just going to have to show you pictures as well. I made a magical door because I wanted to know when people were walking into my Minecraft mansion. So there's some Minecraft circuitry behind here, and when I open the door, the Minecraft circuitry says, hey, the door's open, and it's connected to a PHP script, and the PHP script says, hey, this door's open, and that PHP script's connected to an Arduino, and that Arduino's connected to an alarm, so when the door opens, a real-world alarm goes off for my in-game house. I'm very security conscious, right? Yes. This entire thing is blogged about, including what you need to know about the starter components that form part of that circuit. Resistors and LEDs and buzzers and so forth. And so if you want to go to that URL is a little bit small, but you can go to this, so maybe take a photo if you care about it. I will give you a few seconds to do that. It is a lot of fun to do this, by the way, I must confess. I'm just waiting for photos, it's fine. It's okay, people. All right, done. I lied, though. I'm going to show you how that works in real life. Because I have my mansion. Now, my mansion is not complete. I've been so busy preparing for conferences that I haven't had time to build more than just the front wall. And there are some horses that can just walk into my lounge. I think that's okay. I don't mind horses that much from a distance. But I want to show you some code. Oh, I've given the game away. Let me clear that log. I want to show you some code. First, I'll show you it working, though, because that's far more interesting to me. Yes, okay, all right. My alarm is just starting up. Let me tile these windows. Ooh. I will get there. It's far more entertaining to see this tiled. So, right. I've gone a step further. I'm not content just for telling if someone's opened the door. I want to know if someone's in the area so I can log into the game and shoot them with bows and arrows. Now if someone walks up to my front door... Oh, that's pretty cool, hey? That's really cool. I'm actually going to unplug this buzzer because that's going to be annoying very quickly. Let's see how this is working. I have these 2 command blocks here. Now, command blocks act as a way for you to store a command that you could execute as an administrator in the game. And these 2 command blocks have one very simple purpose. This top one places a redstone block directly underneath it. It's doing that based on the coordinate system. This is a way of writing to memory. Okay, This command block places a block of air where that redstone block would be. Because of the way that charge travels up in Minecraft, the moment you destroy this, that still has a charge and it places a block down here, and then this block gets a charge and so it removes this block, but the charge still flows up here and you can just keep on breaking this indefinitely. This is the most elegant way to do an infinite loop in PHP. It's not like the AND gate, right? Now, because this is continually breaking and remaking, this redstone block, which also emits a charge, is constantly turning this redstone wire off and on. But it's doing it so quickly, it just looks like it's permanently on. Okay, what's this command block doing? It's checking for a player within the radius of the door. Any player moves within 5 block radius of that door, this is going to go off. Okay, that's interesting. This circuit is actually simpler than the one that I wrote about that you took photos of the link for, because it does all of that logic just in one circuit. If someone is within that radius, as I am now, you can see this is being lit up. This is a comparator. You don't really need to know about it, except to say the test that this is doing, because it returns a truthy value, this lights up, so this lights up, so those wires light up. Okay. When I move close to the door, this part of the circuit lights up. And it writes one value, or it sends a charge into this command block that says, say near to the whole map. That's why when I walk close to this, when I walk away first, it's going to say far again. But when I walk near to it, it says near. At the same time, it's sending a charge into this block, which is turning a redstone torch off when it has charge. And when that redstone torch turns back on, it says far. This one circuit with a radius detector is first saying near when I move close, and the moment I move away again, the circuit switches off, and so it says far again, because I'm using that signal inversion, that not. So the circuit is saying out loud, there you see, square brackets at far, and square brackets at near, and square brackets at far. Now, there is some PHP code running here which connects to an Arduino at this dev port. I'd happily tell you how to find that address out, but separately, I don't think it's that important. All that it's saying is that create a new serial connection to this that's plugged in. Then I create an event loop, which you might be familiar with if you've used something like React PHP or something like AMP or whatever. And then I say activate the board. Now, because it's an event loop system, it doesn't block at this point. It just tries to make an active serial connection with the Arduino. And when it's done, it's going to execute this PHP callback. Before it connects, it just prints connecting. After it connects, it prints connected. That's why we see those things over there. Then what it does is it sets the output mode on the pin that the buzzer was on, so that I can start to push signals into it and it can switch the buzzer on. And then I can take the signal away and it can switch the buzzer off again. This is the basics of how my alarm works. Every 500 milliseconds, or every half a second, I'm running this closure as an interval on the event loop. It links to my Minecraft log file. Those messages that the command blocks say of near and far get read in with a file get contents, split by line, return the last one. If the last one says near, turn the pin on. If the last one says far, turn the pin off. And then empty the log file, just because it's a little bit easier to pass. Okay. The Minecraft circuit is writing to the log. The PHP script, using an event loop, is connected to the Arduino and watching the log file. When the log says near, it turns the Arduino buzzer on. When the log says far, it turns the Arduino buzzer off. This is a through line of Minecraft to programming to electronics. And that's a really powerful thing to show. I'll talk a little bit why towards the end. I have 10 minutes left, and I have one more really interesting thing to show you. Back to our slides. I won't go too much into detail about the PHP code. Oh my goodness, come on. Downfall. Hey? Yeah. Oh. Okay. I won't go too much into the PHP code that's backing the next thing that I'm about to show you. I am a fan of the e-commerce platform Shopware, and there are a couple of people from Shopware here that I know about. There's probably more in the audience that I just haven't managed to spot because I'm blind as an actual bat. And their And Shopware, being this commerce platform, you can put products into it and people can go to your site and they can purchase from your site. And it's actually a pretty cool piece of software. And the original purpose of this talk was for a Shopware conference. And so I thought it would be kind of cool if I could connect the two things. There's programming and electronics in Minecraft, but then also Shopware. How do we do that? Well, I set up a Shopware instance on my local system. Let me go there. Oh, there's feedback for your talk. I should hide that. There is this local Shopware instance running on my machine through Apache and PHP 7. And it's not supposed to go straight to that URL. And so I've got in this Shopware instance just I downloaded a plugin or installed a plugin that loads it with some stock testing data. I also configured PayPal on this, but we're never going to get to the point of needing that. Besides the point, it was actually pretty easy to set all this up. And I registered an account with my email address. Okay. Now, I wanted a shop inside Minecraft. And so this really ugly squat building is what happened. But now I want a shop. So let me just say shop. Oh, okay. I have to sort of pseudo-authenticate here. I don't want to type my password in plain text in Minecraft. So in this case, I'm just going to have to say the email address. I'll say email and foo@bar.com. That should be fine. Oh no, email's not found. This custom command that is triggered by a PHP script or interpreted by a PHP script is authenticating with the Shopware instance. It's using its REST API to log me in or to at least check if that email address is valid in Shopware. Because I didn't use an email address I've registered with, I can't shop. I actually have to type the email address I registered with. Which, by the way, if you want to send me hate mail, this is totally where you send it to. Okay, you're good to go. I can actually shop now. Oh, let me put my exclamation point there. It's opened up. And now I will forever be shopping, I guess. But there are no products here. How do I get products here? Well, I made another custom command called refresh. These are really horribly named commands. And these will go into that Shopware application's REST API and pull out the products and their prices. It's doing a lot of complex PHP to do that. It doesn't have to be like that, but that's how I've done it, and it's ghastly. Let's not show that. However, it doesn't do me any good if I can't get updated prices or updated product names. It's going to be a lot more useful if I can keep on refreshing this. And technically, I can. It's returning the most recently updated 4 products. So I'm going to go into this one, and I'm going to change its name. I will go into the backend to do this. And where is it? Overview. And it's this one down here. Okay. Being the creative individual I am, that's the name I'm going to set. Right. Back into Minecraft. On the slidey mouse. Refresh. Ta-da! I spent a very long time trying to go all the way through the checkout process. Turns out the old version of Shopware that I'm using doesn't entirely support that. I can still create orders. The new version of Shopware that's coming out is completely API-based. So I would be able to register as a customer in Minecraft, refresh the products, purchase them, and check out inside Minecraft. Okay. Now I'll talk for a minute about the purpose of this entire talk. Let me just get out the shop quickly before I die in here of starvation. And I will leave it on the screen because I really want you to see that feedback link to leave me feedback. But what is the purpose of all of this that I'm telling you? It was a different purpose at Shopware, by the way. The purpose of me giving you this talk is because I want you to see a game used for more than just what a game is typically used for. I want you to see what you are in, or what your family is in, or what your kids are in, or what your siblings are in, or what your parents play, if they are awesome. And I want you to see it as the unobtrusive teaching environment that it is. We've seen conditional logic, and we've seen electronics mapped out in Minecraft. We can make OR gates and AND gates and signal inversion. We've programmed in these 45 minutes. And then I showed you programming I did, not in these 45 minutes, to be able to replicate an oh my goodness. Let me get something to drink. And then I showed you a circuit that I did a while ago that mimics an electronic chip that you can buy in the shop just with Minecraft wiring. And then I showed you some PHP that we can use to connect to these servers and to do really awesome things like interact with an e-commerce application to fulfill orders inside Minecraft. And if you're seeing anything, you should see that people playing this game for the game don't know that it can do this. But you can start to introduce these concepts to people you know without them knowing that they're actually learning. Hey, that's a cool game you're playing. Did you know you could do this thing? Oh, okay, you've done that. That's awesome. What about this little thing over here? And slowly you can teach someone to program or to enjoy hobby electronics. You can do it cheaply with these cheap components I've shown you with. You can do it just with code. But you can do it in a game. And it's not just limited to this game. Look at the things around you that you can use to teach people about what you do, or to have fun with them, or to help grow closer together doing an activity that both of you enjoy. That's what I want you to see from this talk. If you have questions about doing any of this or replicating any of this, please speak to me on Twitter. I love talking about this all day. And if you have a moment, please, once you go to Joined In, and leave me feedback about how I can do this better, because I really want to be able to do this to more people to help them to see the same value in games that I see. Are there any questions? Yes?
What is your opinion on in-game purchasing since you
That's a good question. What's my opinion on in-game purchasing? I don't like it, but this was the only way I could link it to Shopware because it's a commerce platform, so forgive me for that. There was another question. Yes? This, the reason that I have to run this map on multiplayer is because there is an admin protocol that runs on multiplayer called Archon. And with Archon, I can connect from PHP over something similar to a socket connection and issue administrative commands. Just like I can say toggle downfall in here to switch rain off, the PHP script on the other side of that Archon connection can say the same thing, and that will affect this game. There are lots of games that also support this protocol. Counter-Strike Source did until a little while ago, I think. Rust, which is kind of popular, still supports this. There are many games that have this Archon protocol. There are many games that don't, but they have other similar things, or at least log files. And as we've seen from log files, there's a lot that you can still do. Maybe you can't write into the game, but you can read out of it to do useful things. This is the only game I've experimented with because I used to like it just to play survival or creative, and this was a nice branch into that. And because this model's programming so nicely, I can do programming inside here and use that outside. But that's a nice question. Other questions? Okay, well, thank you for being here.